In these problems, we're dealing with quadratic equations. Whenever you have an x term that's squared, it's going to end up being a quadratic. And these particular problems are fairly easy to solve using something called the square root rule. And you probably would know if you were to take the square root of 4, you'd get 2. Although you might remember that it could be a negative 2 as well. Because negative 2 times negative 2 is 4, as well as 2 times 2 is 4. So when you take the square root of something, you really, and this is more conventional answer, you really write it as plus or minus 2. Okay? That's important to remember. That's going to come into play in all these problems. Now here, we've got this x minus 5 in parentheses squared, and instead of trying to square this and, FOIL it out and all that stuff, and then subtract the 16 to set it equal to 0, and then maybe use a quadratic formula, we can skip all that and just take the square root of both sides of the equation, as long as we remember to do plus or minus over here. So the square root of this squared is just this, and the square root of 16 is plus or minus 4. So what that does is really give us two different answers, and that makes sense for a quadratic. Now I'm just going to go ahead and get x alone here by adding 5. So you have to be a little bit careful. So x equals for a positive 4 plus 5, so that would be 9, or x equals a positive 1. So those are our two solutions. You might see it like this, 1 comma 9, as an answer. Let's try another one. Now this one's got an extra step in it, because before we take the square root, we want to isolate this thing in parentheses squared. So I'm going to add 90 to both sides. So that's 2 times x minus 1 squared equals 90. And then I'm going to divide by 2. And that will isolate our squared component here. And 90 divided by 2 is 45. Now I can go ahead and take the square root of both sides. And remember the plus or minus, so x plus 1 equals plus or minus the square root of 45. And then let's see, can we simplify that? 45 is 9 times 5, so we could say x plus 1 equals plus or minus 3 times the square root of 5. And then I could subtract 1 from both sides. And I could write this like x equals negative 1 plus or minus 3 times the square root of 5. And that might be the simplest way to write that one. And that would be our answer. All right, let's try one more. This one I don't have to do any shenanigans with it before I take the square root, because our squared piece is isolated over here. So I'll take the square root of both sides. I get 3x minus 4 equals plus or minus 5. And then I'm going to have to add 4 and divide by 3. So let me just do it this way. I won't do two separate problems for right now. I'll just write 4 plus or minus 5. And now we'll divide it by 3. And I get x equals 4/3 plus or minus 5/3, and I could figure it out from there. So 4/3 plus 5/3 would be 9/3, and 4/3 minus 5/3 would be negative 1/3, and 9/3 of course is 3. So my answers would be 3 and negative 1/3. So that's how to solve these quadratics with the square root rule.